So let me welcome you here on the Linux Days. I'm really glad I'm the first presenter in this room. And to introduce myself, my name is Tomsa. I work at Showmax, and today I will be talking about Sinkholing, which is a tool we designed to protect our distributed platform from various attacks and password guessing attempts from the internet. So what is Showmax? We built an online video streaming service built upon a microservice architecture. We serve customers from European Union and Africa, and we try to pay good attention to logging, because in order to control and monitor such large platform, we need to log really everything. And we are working from Prague and from Berlin. So what is sinkholing and why we actually designed it? Well, as every company grows and gets to public knowledge, many people start to notice it, and some of them maybe even too much. Then they try to hack into our platform, use brute forcing to guess password, etc. And that's the case why we designed sinkholing, to protect us from this misuse. Sinkholing in our way is made of three main parts. One is some kind of centralized decision-making mechanism that looks for the offenders and hacking attempts. Then there is some kind of persistent storage where we store the results from the decision-making mechanism for other parts of the distributed sinkholing to take. And the last and most important part is actually the tool that does all the blocking. Before we can design such a complex and distributed tool as sinkholing, you need to get to know the platform you are building it for, so you are also able to seamlessly integrate it into it. So let's take a look at the path of requests that hits our platform. Each HTTP request that hits Showmax ends up in HA proxy, which is a HTTP load balancer that we use for some basic preprocessing and validation of requests. And we also do some header manipulation. Then the request is sent to Varnish, which takes care of caching and routing to our containerized backend microservices cluster. And as I mentioned earlier, each and every step of each request that goes to our platform is properly logged in real time into Elasticsearch. For those who don't know what is Elasticsearch, it's a really fast and distributed and scalable document database to get you up to speed about what means log everything. What means to log everything? Well, we have more than 90 nodes purely dedicated for Elasticsearch, and we are able to ingest regularly more than 160 messages a day, 160 million messages a day. So as I said, that we log everything, that means that all the information about the request you would like to find and all the information about the attackers that try to hack into Showmax are stored in the Elasticsearch. So it means the Elasticsearch is the one single truth source for the sinkholing. With that, we are equipped with a really powerful tooling for searching of them, because all the data about them is in the Elasticsearch. And using the Elasticsearch and its stack, we can do the search really easy. For example, if you would like to search for someone who tries to guess a password, it's really easy. You just have to Kibana. Kibana is some kind of interface that allows you to search Elasticsearch, and you just need to search for the endpoint that is responsible for logging in, and also the HTTP code that means some kind of failure. So in order to find unsuccessful login attempts, you just do this search, and that's it. it's quite easy. You have a whole list of unsuccessful logins. And based on this information, you can proceed with banning according to some rules. Of course, doing this manually would be really slow and not sustainable in our case, so we needed to find a way to automatize, otherwise you would have to buy an army of monkeys that would do the search all the day, you know. So for automatization of this task, we found a perfect tool that's called LinuxAlert. That's a service that periodically queries Elasticsearch and is able to raise an alert when a match according to some set of rules is found. To show you how it's easy to configure, I have got a short example of how to find the password guesses from the previous slide converted into the LinuxAlert. So on the top part, you can select the type of rule the LinuxAlert will be following. The type frequency means that it will alert you when there is a certain threshold of events reached within some time frame. In this case, 20 events within 1 minute. The middle part is the actual query for Elasticsearch that you saw on the previous slide. And the last and say most important thing is the alert. Here you can specify how you want to be alerted when it finds when the alert finds what you want it to be found. You can use various built-in alerts like email or messaging clients, etc. But you can also create your custom alerter, which we did in our case. So now we know how to find the attackers and various hacking attempts. Now we need to publish this information for other parts of Sinkhole. So we don't need any special features of classical relation databases for that. We need just a fast key value storage. So for that we have selected it to be Redis. It also elegantly solves automatic unban because we can use its key expiration for that. So in order to get the information about found offenders from Elasticsearch to Redis, we've designed our custom LinuxAlert alerter, and it's actually pretty easy to do. It's written in Python, so you just have to subclass the alerter class, implement the alert function, and this function receives a list of results from Elasticsearch that matches the query, and you just extract information you are interested in. In our case, we extracted IP, wrapped it together with some additional info into JSON and pushed it to Redis. Okay, so now we know how to find the offenders, how to store information about them, and now comes the part when we will be blocking them. We had a decision to make. We were deciding between HA proxy or IP tables. For some basic usage, IP tables would be sufficient because if you need to block only by IP, it's quite okay for that. But we wanted to be more targeted in the banning. We wanted to be able to address issues of people behind NAT, etc. So for that we have chosen HA proxy because it has more features for intruder detection, because it can look directly into the requests. So with HA proxy we are able to block not only by IP but also by user agent, request content, etc. And if there is something that HA proxy doesn't provide, we can always extend it via Lua scripts. It also offers us to send back a synthetic response telling the users what actually happened. And another plus is that we already use it in Showmax, so we won't add any more tooling to that. That's not required. So let's take a look at some example how to configure HA proxy to find a request based on its IP. For that, HA proxy provides a powerful tooling called ACLs, or access control lists. It allows us to extract the information from request, from response or environment, and make some conditional logical, some decision based on the informations we received. The HCL itself resolves to true or false according to its configuration and according to the request it receives. So let's take an example how to find requests that come from a list of IPs. It's quite easy. You just define the ACL, its name, then you tell the source for the information of the ACL. In this case, we told it to look at the source of the request. Then you tell it to look for IP address, not to resolve DNS, and then you provide the list of address you want it to match. This static IP list is really not that useful for us because we want to be able to change it dynamically, otherwise we will have to always reload HAProxy to apply new settings. Luckily, HAProxy allows dynamic control of these lists, and it can be done via socket. For that, you need to only change slightly the rule. You don't need to provide an initial list of IPs, and you have to specify a certain unique ID of the ACL in order to be able to control it later. So, how to control it via socket? You just head to the main configuration of the HAProxy, and the global settings you just specify the socket. Where should the socket be? For controlling via socket, you can use add ACL, show ACL, and clear ACL commands. There is only one downside of this approach, because if you want to remove a certain value from the ACL, you cannot do it. You have to clear the whole ACL and then refill the rest of the values. So your tooling must be ready for this. So this is the only downside we found. Well, then there is a front-end section which actually defines the ACL and makes some kind of decision in case the IP of the request matches the IPs from the list. If it happens, it tells it to use backend for sinkholing, and its definition is down there. And these two lines are actually the sinkhole, the real sinkhole of the sinkholing, because this is the place where the requests and their path. So if you paid good attention, you know that there is only one last piece missing to solve this puzzle, and that is that we need to fill the HAProxy's ACLs. For that, we designed a short Python script that regularly fetches information about bans from Redis, compares the list to the currently banned IPs, downloads only the updates, and fills the HAProxy. Of course, if a ban has disappeared, it needs to clear the ACL and refill the rest. Well, for communication with HAProxy, we use HAProxy admin Python lib, which allows the control via the socket. Well, when we were designing and deploying this thing, we learned the hard way that Africa is really far. When we were designing it and testing it, it all happened in Germany, so it was not an issue. Everything worked okay, but when we deployed it to production, suddenly sinkholing stopped working in Africa. Actually, it went mad because it took more than 15 minutes to run this first cycle. So actually the bands has completely changed during that time. So it was doing nonsense in the Africa. So after some debugging, we found out that the function that we use for iterating did it in batches of 10. So it took really long time to iterate all the keys in batches of 10 because the handshake took more than 200 milliseconds to get to Africa and back. So it really So in the end, we ended up with a count of 1,000, and the time decreased from 15 minutes to 5 seconds, so now it's usable everywhere. So the lesson to be learned here, you have to know the network you are dealing with and design your tools properly. So yeah, that's it. Let's take a look at some high-level overview of the Sinkholing. So every request comes to HA proxy, it's locked in Elasticsearch. Then Alert regularly fetches info from Elasticsearch. When it finds something useful, it pushes the information to Redis, from where the HA proxy updater script fetches the information and applies the bans. So now it's time for some statistics. In the last month, we were able to give almost 19,000 bans. We blocked almost 1.6 million of requests from banned users, and those requests came from 86 different countries. And you would probably want to know which was the worst, and the most requests came from Russia and Ukraine. There is a picture of our monitoring dashboard for Sinkholing. You can see some graphs of currently applied bans, some URLs that were most affected, users that were banned, etc. So if you would like to know more, you can go to our blog post to see what we are doing at Showmax, and there is also a first part of my blog post about Sinkholing. You can learn it there. And of course, if you want to know even more, you can always apply for a job because we are hiring. So thank you for your attention, and now it's time for questions. Any questions?
Okay, you mentioned 1.6 million requests per day.
You mean that we blocked 1.6 million requests?
No, the average load or the maximum, I'm not sure.
You mean the messages we ingest into Elastic? It is 160 million messages per day. Yeah.
That's your average or a maximum that the platform is able to?
It's some kind of average. Yeah, it's able to ingest more. It's actually not a request, it's the number of messages we store into Elastic. But so every request produces multiple messages through its way through our platform. Okay.
Does it support IPv6?
Well, the question was whether it supports IPv6. Currently we don't use IPv6 as Showmax, but the tooling is kind of ready for that. You can notice that there is client IP4, so there's no problem to update the tooling to match to work with IP6, etc. You just need to reconfigure the HA proxy, etc. Well, and I forgot to repeat the previous question. The previous question was asking about the number of logs we ingest into Elasticsearch daily. Some other questions? If no, you can always talk to me down here offline. And thank you for your attention, and enjoy the rest of the LinuxDays.